Hi everyone, as we're about to start our course on calculus, I wanted to spend a few minutes to discuss what a derivative is, as well as what differentiation is. And for that, we're going to be looking at the three graphs that we have on the screen right now. The objective being to look at the gradient or slope of each of the graphs that we have. So let's get started. If I look at the first graph we have here, this is a straight line graph. And this function's equation is the one we see here, f of x, which equals to 2x minus 4. Now, if I were to ask you what is this line's gradient or slope at, say, this point here, I'm sure you'd have no trouble telling me that it's equal to 2. The reason being this line's equation would be y equals to 2x minus 4, where 2 is its gradient or slope. And consequently, at any point along this line, the gradient or slope is still just 2. And in fact, what makes this straight line straight is the fact that the gradient is always equal to 2. But now look at the second graph we have here. This is a parabola, and its equation is f of x, which equals to x squared minus 8x plus 12. Now, what if I were to ask you what's the gradient of this curve at this point right here? Or even at this point right here? Well, first of all, how do we even define the gradient or slope of a curve like the one we have here? Well, here's the idea. The gradient or the slope of a curve at any point along its length is defined as the gradient of the tangent line to the curve at that same point. So for instance, at this point right here, the tangent line would be something like this yellow line I'm drawing here. And so the gradient of the curve at that point would be equal to the gradient of this tangent. Similarly, at this point here, the gradient of the curve will be equal to the gradient of the tangent at that point. So that would be this pink line I'm drawing right now. There we go. Now looking at these two tangents, it's very clear they don't have the same gradient. And so the whole idea behind differentiation and finding the derivative of a function is to provide us with a way of finding the gradient or slope of any tangent line to the curve at any point along its length. And in fact, that's the first thing we're going to be learning how to do in calculus. And we'll be learning many rules to learn the method for various functions. But here, to give you some idea, starting from a function f of x like this one here, to find its gradient at any point along its curve's length, we use what is known as this function's derivative function. And for the sake of this video, I'll just go ahead and give it to you. This function's derivative function would be written f dash or f prime of x, and it's equal to 2x minus 8. This function is known as the derivative function or derivative of the function that we started with. And the process of going from f of x to f dash of x is known as differentiation. But so how does this work? Well, let's look back at the two tangents I drew here. And for argument's sake, let's say that this yellow tangent corresponds to the tangent when x equals to 5, and we'll say that this pink tangent corresponds to the tangent when x equals to 1. Now back to the derivative function, if I want to calculate the gradient of this yellow tangent and therefore of the curve at this point, all I have to do is replace every x I see in this derivative by 5. And I'd write that like this. That would be f dash of 5, which equals to 2 times 5 minus 8. And that's equal to 10 minus 8. In other words, f dash or f prime of 5 is equal to 2. And this 2 is the gradient of this yellow tangent. And consequently, we can say that this function has a gradient of 2 when x equals to 5. Now let's find the gradient of this pink tangent, which is going down as we go from left to right. Remember, that's the tangent at the point whose x-coordinate is 1. So to find the gradient, I replace every x I see inside the derivative by 1. And that would be f dash or f prime of 1, which equals to 2 times 1 minus 8. In turn, that's equal to 2 minus 8. And finally, f prime of 1 is equal to negative 6. Done. So this pink tangent, and therefore the curve at this point, has a gradient equal to negative 6. And so this quick example shows you what the derivative function will allow us to do. We're going to be able to calculate the gradient of a curve at any point along its length. Indeed, To calculate the gradient of a curve at any point along its length, all we need is the derivative function. And for that reason, it's often simply called the gradient function, because the output value of the derivative function is always a gradient. Now, looking back at the first example we had here for a second, which was a straight line graph whose gradient is always equal to 2. And in fact, as we'll soon be learning how to do, we could show that this function's derivative function would be f dash or f prime of x is equal to 2. And so regardless of which point along the line we're looking at, the gradient is always 2. Now let me quickly look at this last example. We have this green curve here, and its function is f of x, which equals to x cubed minus x squared minus 17x minus 15. And once more, I'll just give you the derivative function, and that would be f dash of x, or f prime of x, equals to 3x squared minus 2x minus 17. And again, this derivative function can be thought of as the gradient function for our curve. Using it, we can calculate the gradient of the tangent to this curve at any point along its length. So for instance, let's say we're at this point right here, and I'll say that the x-coordinate there is negative 2. Well, the tangent to the curve at that point would look something like this. Got this yellow tangent right there. And to find the gradient at this point, all we have to do is replace every x we see inside the derivative by negative 2. And that would be f dash of negative 2 equals to 3 times negative 2 squared minus 2 times negative 2 minus 17. And that's equal to 3 times 4 plus 4 minus 17. And that's equal to 12 plus 4 minus 17. Finally, since 12 plus 4 is 16, minus 17 is negative 1, we can state that the derivative function when x equals to negative 2 is equal to negative 1. And that's the gradient or slope of the tangent to the curve at this point, which we say is the gradient of the curve at that point. And there we go. That's what the derivative function allows us to do. Using it, we'll be able to define the gradient or slope of a curve at any point along its length. And so our next steps in this course will be to learn all the tricks and techniques for finding the derivative function. And there we have it. We now have a better idea of what a derivative is, as well as what differentiation is, and hopefully you now have a better idea of why we'll actually be learning about differentiation. And that's it for this tutorial.